Fine. Am I audible now? దాంట్లో వస్తున్నా డైరెక్ట్ గా వచ్చేస్తున్నా వాయిస్. ఓకే, రైట్. So yes, I think I've opened it. I'll put a different folder for Kubernetes altogether. Okay. Right. So we are supposed to speak about Kubernetes. Okay. Right. The basic purpose why we use Docker Swarm and why we use Kubernetes is same. Let it be Kubernetes or let it be Docker Swarm, we are not speaking about single machine. We are speaking about a multi-machine kind of a scenario, right? So we'll use Kubernetes when we have to basically deal with multi-machines, right? So I'll be getting into very simple points. We'll understand that, and then we'll get into to dive deeper. Okay, right. So let me basically see. Right. Okay. Right. So you have all the stuff which is present over here. Okay, but I'm not going to touch all of them today. Let us make our life very much simple so that we'll understand what is Kubernetes all about. Okay, right. So first, where is it used? Where is Kubernetes used? Okay, for any container deployments. Okay, which require automatic scaling. Okay, what do you mean by automatic scaling? When the load on your particular application is increasing, it should automatically be able to increase more containers. So yesterday in the Docker, I think I have executed one simple command called as Docker swarm scale and all of that stuff. That was a manual way of doing it, but I want it to be in an automated fashion, right? Okay, right, for automated scaling. And then for the other one is which are microservices. Okay, so for example, if your application is a microservice, Kubernetes is the best thing to be done. Okay, so if your application is a microservice, Kubernetes is probably the best thing that can happen to your application, because while starting my application itself, my application will be designed in a way saying that we'll be dealing with Kubernetes. So it will have all the necessary parts. So for example, your application, right? Whenever your applications are working, you would have your application, you would have a database, and your application to connect to the different systems might read some config files. Okay, your applications might require to store some passwords or store some sensitive information. Kubernetes has all of it. Kubernetes has all of it. Okay, so we'll come back to that. So microservices. Okay, and then remember volumes. Yes. Okay, volumes mounted to, okay, EBS. If you the people who belong to AWS know, I'm quite sure what it is. Okay, it is a virtual hard disk on Amazon. Okay, so Azure disks are most of third party virtual. So yesterday someone was asking me, so how will volumes work? Okay, because all these days we were working with single system, we were binding the mount or we were creating the volume. Our Docker was in the same machine, our volume is also on the same machine. Now the problem which we have is the moment we go to the multi machine, okay, you have multiple machines wherever your container can launch, and where will volume be located? Okay, so my volume might be present in Amazon or in cloud or in my office in VMware, right? So it can be at a shared location so that all of my containers can basically reuse it. Okay, and then the most important thing is, okay, for any containers which require zero downtime, okay, because here we can set the deployment strategy. Okay, you can have something like rolling update, canary deployment. You can go with different kinds of it. So today you might not understand what a canary or what is the green blue or blue green, whatever it is you call it, different kinds of deployments, but we can set the strategy over there. So when I am basically designing my application in container, okay, which is not speaking about one service or one machine, then the obvious answer for me is Kubernetes. Okay, so where the Kubernetes is used, almost literally anywhere. Okay, so now, okay, why Kubernetes? Okay, so why not Docker Swarm and why Kubernetes? Right. So we have been using Google search from ages, right? Yes or no? We have been using Google Mail from ages. Okay, so the Kubernetes is first is it was written by Google, and then okay, they made it a okay. Let me not go into all of this. Then I'll write it in a very simple term. Then they made it as they made it available to others. Okay, so generally in movies, especially, I'm not sure how many of you see Telugu movies, right? మాది మా వంశంలో అందరూ సింహాలే ఉన్నారు ఇలాంటివి చెప్తుంటారు కదా. సో ఐ హ్యావ్ ఎ ఫ్యామిలీ ట్రీ వేర్ వీ హ్యావ్ ఆల్ లయన్స్ అండ్ ఆల్ దట్ స్టఫ్. And these days, even the people who watch Hindi movies, there are a lot of South Indian movies, Telugu movies, especially getting dubbed to this. Okay, if you have watched any of the movies which they have a lot of action, then there will be definitely some dialogue on family tree. Okay, so అలాగా సింహాలు పుల్లు వంశం నుండి వచ్చింది కుబర్నెటస్. The reason is why it is basically called as okay. Our Google search used to basically work on different container technologies, right? So Google had okay has in-house products. They have something called as Borg. They have something called as Omega. Okay, so they use this to ensure that your Google searches are working effectively. Okay, your Google mails are working effectively. They use that container technology, right? So Kubernetes is built based out of Google's experiences with Borg and Omega. Okay, so they have a very strong background, strong set of popular use cases. And if you see Google search is probably most used stuff throughout the day. And if Borg and Omega are able to handle it, Kubernetes also should be able to handle it, right? So because they have brought in majority of the learnings from there. It is not the same product they have rebranded. No, they have rewritten it. Okay, but the whole point is it has all the learnings which Borg and Omega has. Am I clear on this? Borg and Omega, there is no need for you to know the tools, but if you are using Google search, you might have used one of them internet. Okay, so that's the whole point. So it has a DNA which comes from a very stronger background, very proven background. That's where it has become popular, right? And then one more thing is Kubernetes. Okay, miss something. Kubernetes runs anywhere now. When I say anywhere, it is running on AWS, it is running on Azure, okay, it is running on IoT platforms, okay, it will run on plain Linux machines, it will run on plain Windows machines, okay. You can go on and on. This list goes on and on. Okay, so Kubernetes is available almost at all the places. Am I clear on this? Yeah. Okay. So where is it used and why is it used? Okay, fine. So right here I forgot one more thing. Okay, effective load balancer integration. That is not load balancing is done in Kubernetes in Docker Swarm also, but here basically what has happened was, right, for example, if you are using AWS has three kinds of load balancers. You can integrate Kubernetes with the existing load balancers easily. For examples, in your company they might be using F5 load balancer. F5 is very popular in load balancer, or HA proxy. There are many load balancer products. Kubernetes has lot of inbuilt support for this, so you can very easily bring or basically navigate your containers through the existing load balancers. So that's where it comes into play. Okay, right. So am I clear on this? Yeah. Okay, so next, basic working style on Kubernetes. Okay, so if you want to work on Kubernetes, what will be your working style? Typically, what is that you would be doing? Okay, right. So now, okay, let us assume that you want to send a courier. You want to send some courier to one of your friend. Okay, so in that courier, whenever you want to send that courier, what will you do? What will be your steps? Let us assume you want to send a pen drive. Okay, from here to Bangalore. Okay, or Delhi. What will be your what is your workflow for doing that job? You have packed it. Okay, good. Next, pardon me. Okay, to address and from address. Okay, and then స్టాంపా? కొరియర్లో ఎవడు స్టాంప్ తీసుకుంటున్నాడండి? ఎవడు తీసుకోవట్లేదు స్టాంప్. మీరు అసలు బతిగా పోస్ట్ ఆఫీస్ని బాగా గుర్తెట్టేసుకున్నట్టున్నారు. రైట్, అంటే ఆడు కొట్టే స్టాంప్ గురించి మాట్లాడుతున్నారా మీరు? ఓకే, ఓకే, ఫైన్, ఫైన్. సో బేసికలీ వాట్ వీ డూ ఓవర్ దేర్ ఇస్ we will have our package, and then what we will be telling to the courier provider is, okay, this is what I want to basically it should be done. This is my from address, this is my to address, I have this contact information. Okay, that's it. You give it, your courier will be done, you will be getting the acknowledgement, and you will be getting the track the order. Yes, this is what it is. Or will the process will be like this? Okay, now I have packed it. You give to the courier provider and you say that, okay, my lucky number is 9, so ensure that you are basically carrying this package at 9 a.m. in the morning. Okay, till airport, go in the Ola cab, and from there ensure that you are traveling in Indigo itself. I don't like SpiceJet. Okay, so once you go down in Delhi or Bangalore, take the courier in Uber now. So we have to do enough justice to Ola and Uber. Will you do that, or will you just tell all of this? Yes. So what is the basically difference between you writing from address and to address, okay, and then just getting enough information so that you can track the order, versus you telling everything? Are you getting the whole point? So in the earlier case, I've given you two examples. In one case, you were just telling what is your from address, what is your desired date by which you want your order to be received. Okay, and then you will get a tracking order. Okay, the tracking order will tell you whether the product was delivered or not. If the product is delivered, you will get the acknowledgement. This is how courier works. The other example which I've given is you are going and then you are trying to tell how to do everything. Okay, so Kubernetes working style is create manifest. Manifest is like your from address and to address. Okay, with okay minimal information. Okay, okay, and all of this information is which will be desired state. Okay, now one thing is this manifest will be written in, yeah, am I clear on this? So you'll create a manifest file and that manifest file will be written in YAML. Okay, and then you will basically get your desired state. Am I clear on this? So in Kubernetes, what is that I am supposed to done? I am supposed to learn how to write that manifest. Now I want to create a Kubernetes volume manifest. I want to create auto scaling manifest, right? So as a Kubernetes person who, because Kubernetes has two kinds of users. Okay, one is someone who is called as application developer, the other one is called as administrator. Okay, there is some amount of common path, but after that the paths separate. Here I am speaking about the Kubernetes administrator, right? So you as a Kubernetes administrator will basically upload manifest files and you will get results. Okay, and you should know troubleshooting. If something goes wrong in Kubernetes, where do I find that information? Am I clear on this? Right? So is this simple? So to work on Kubernetes, what is required now? Just writing a YAML file according to Kubernetes definitions, right? So yesterday in Docker Swarm, we have discussed about certain things, right? So saying that in Docker Swarm, we have something called as node. Nodes are of two kinds, worker node and manager node. And then we have said that there will be something called as service and there will be something called as task. Okay. There are other areas of networking also, right? So similarly, Kubernetes also will have certain things like that, right? So I'll just name, I'll not write it. So in Kubernetes, we have something like pod, right? To write that pod or to create that pod, we will be writing something called as pod spec, which is a manifest. Okay. That manifests are also referred as specifications. Okay, so whenever you write a manifest, why are you writing that manifest? You are just telling what do you want, not how do you want. Okay, so for example, in manifest you will never tell that I want 3 containers to be created by using docker container run command. No, we will not speak about all of this. You will just say that I want 3 containers with the following image. That's it. You'll not speak more than that. For example, if you want to expose ports, you will speak about what is the port that has to be exposed. Yeah, so you will always be telling about what is that you want rather than how it is done, right? So now if you want to do troubleshooting, yes, you need to know the commands, but to basically work with Kubernetes, you need to do this activity. So am I clear on this? So in Kubernetes, what is that we'll be writing? We'll be writing specifications or manifest in a YAML file. So if we are good at YAML, I think it should get our job done. We should be able to do our job. So now what I'll do is I'll basically speak about, okay, Kubernetes architecture. Okay, but I'll not be trying to write the whole architecture. I'll be trying to write a very simplified one. Okay, so I'll be basically trying to tell, okay, first view. We will have a better view at a later point of time, but first let us start with a view. So in Kubernetes, what would happen is, okay, it is a cluster. The moment I say cluster, you will have two kinds of nodes. Okay, one who manage, one who do the job, like Docker Swarm itself, right? So in Kubernetes also we'll have nodes. Okay, let me use different colors. Okay, not this. Let me not use blue. Let me use black itself. For master, let us use black. Okay. In Docker Swarm, we have called them as managers, but here we call them as masters. Okay, and let me write them as master. Okay, now along with master, we will obviously have nodes. Okay, we'll have nodes. Am I clear on this? You'll have master and you'll have nodes. Till this point, you'll not see any difference between this and Docker Swarm. When I start speaking, like diving a little bit deeper, then you will find a difference. That is the whole idea. Today, I want to basically stick at the top level so that we know what we are trying to do, right? So now let us go back to the let us go with the same user. Okay, so you have a user. Okay, and this user will not be speaking with nodes, but he'll be speaking with. Yesterday also user was speaking with manager, not with workers, right? Okay, so one way which he can speak is, okay, let me use this. Okay, he can speak to the master. Okay, by using command line. By using command line. So this command line is terminal symbol which I have done. Okay, and you will learn that it is called as kubectl. So to speak with master, you need something called as kubectl. If you remember, to speak with Docker daemon, we used to use something called as Docker client. Okay, Docker container run. Then what would happen? This command will take your input and it will give away to the Docker daemon, and Docker daemon will do the job for you. Okay, and then along with that, we have, okay, this sounds, what should I use? ఇదంటే మళ్ళీ క్లౌడ్ లో ఉంటుంది అనుకుంటున్నాను, అదే వచ్చింది సావు. I'll use this. Okay, so you can, one more thing which you can do is you can use an API. Okay, so as a user I have an option. Okay, so you can go via kubectl, and from kubectl you'll be interacting to masters, or you can go via API, and from API you'll be speaking with master. If you are following this kubectl route, you need something called as YAML. If you are following this route, you would be using something called as, am I clear on that? So our route is mostly using kubectl. Okay, so as whatever we write, we will be basically using kubectl, but your Kubernetes master is just not restricted to that. So this API is a REST API, and that can be called from any language, but they have inbuilt APIs for Go and Python. So if you are writing Python, you can directly speak by writing code with Kubernetes. Okay, But our job is not that. We are not worried about that. That is developer's job. So we are worried about that kubectl. And now kubectl basically speaks with masters. We have multiple masters. Why? Because of high availability. If this master goes down, we have one more master doing the job. Am I clear on this? Yeah. So, and now what will master do? Master will get the work done on by scheduling some work on the nodes. In the Docker, right? We create Docker containers, right? In the case of Docker Swarm, we create tasks. Yes. Okay. So here, okay. What is the pod symbol which I should be using? Yeah. So in Kubernetes, what is that you create? Okay. Am I clear on this? Okay. But pods are not like Docker Swarm's tasks. Docker Swarm's tasks are logical in nature. Here, pod is actually something which exists. Okay. Am I clear on this? So in Kubernetes, what we do is we speak with kubectl or we speak with API. Okay, if you are speaking with API, you have to use JSON. If you are speaking with kubectl, you have to use YAML. And then we speak with master, and master will get the work done. And generally, the smallest unit of work is pod. Okay, and within this pod, inside this pod, you have a Docker container. That is what it is trying to tell. That blue area is pod. In that, the white logo which you are seeing is a Docker container which you see. Okay, and one more thing is Docker Swarm works only with Docker containers. Whereas Kubernetes was not only designed for Docker containers, it was designed to build with any container technology. Okay, so Kubernetes in Docker containers వేరే రకాల containers కూడా create చేసుకోవచ్చు. Yeah, but majorly people use Docker. That's a different story. But tomorrow, if new container technology comes in, we cannot use Docker Swarm, but we can use Kubernetes because Kubernetes is designed to work with any container technology. Okay, so right now there are two popular one is Docker, the other one is Rocket. There is one more container technology which is called as Rocket containers, RKT containers, right? So Kubernetes works with both of them, whereas Docker Swarm cannot work with other stuff. It is specifically designed for Docker. Okay, but undoubtedly Docker is the most widely used container, so you need not worry about Rocket. Okay, so even though Kubernetes calls it as a feature, but most of its workloads are on Docker. Am I clear on this? So what is your way of working? You as a user have two paths. Okay, kubectl and API. Our path will be kubectl. Okay, we'll be writing YAML specifications and then running it. Okay, but if I want to write code and then control Kubernetes master, then I'll be going via API route. I'll be going via API route. So clear? So I've just written pod, but there are many other things. Okay, so there is something called as services also. In Kubernetes, we have something called as pods, services, replication controllers, right? Replica sets, deployments. Okay, so ingress. There are many things to learn over here, but the basic idea is we have to start at some point. That some point is we as a user will be once we have a Kubernetes, we'll be basically going through this. Am I clear on this? Right? Okay. Now, first let me save this image. Then I'll speak about Kubernetes as a service. So for example, if you go to Azure, you will get Kubernetes as a service. You go to Amazon, you get Kubernetes as a service. You go to some of the cloud applications, they will give you Kubernetes and you can directly work on Kubernetes. So what is the difference between using cloud and installing Kubernetes on your own? That's the only thing we will discuss, right? Okay. So right. Okay, so user, okay, connects with Kubernetes master, and master gets the work done. When I say work done, the concept is set. Work done is equal to desired state is equals to actual state. This is what even Kubernetes will try. Desired state is equals to actual state. Okay. Work done, sorry, on nodes. Remember these nodes in some of the documentation you might see them called as minions. Okay. Earlier we used to have this master and minion kind of stuff. I'm quite sure you know minion, but for the people who don't know minions, I'm quite sure you'll be able to find it out now. I'm quite sure you might have seen this, right? This is a minion. So earlier, the Kubernetes node was called as minion, which was a wonderful name. I'm not sure why they have renamed it as the node. Okay, but earlier when Kubernetes started, those nodes were called as minions. So we used to have master and minions. But even today, some of the people still like this convention, minion convention. Right? Yeah. Okay. Fine. On nodes. Okay. So Kubernetes okay, has two popular ways, okay, of communication to master from users. One is command line tool, okay. So the second one is REST API. So the command line tool is basically called as kubectl is the command line tool, okay. Kubectl, okay, works in, okay, declarative and imperative. So what is this declarative and imperative? Yesterday whatever I've done in Docker Swarm was imperative. What do I mean by that was, for doing anything I was typing commands. Okay, if I have to do the same activity again, I have to type the same command again. Okay, declarative way means you are not doing that. You have written one file for that. Whenever you want to execute that, you will be just executing that file. So for example, in here in Kubernetes we have declarative and imperative way. So for declarative fashion, this is the most popular one, declarative way, we use YAML files, okay, which are called as specifications, right? But you can get the work done from command line also, like what we have done in Docker Swarm, but that is good while you are learning, not very good in production systems. In production systems, it is always recommended that you have specifications, right? And the REST API, JSON based REST API is exposed. Simple. Okay. Now you can connect to this REST API using whatever language which you want to, and then start speaking with Kubernetes. Okay. But in the Kubernetes, I have just written two components, right? I've basically given you high level components, master and node. But in master, there will be four major components. In node, there will be three major components. Okay. I am not speaking about that now. So in master, there will be four major components. In node, there will be, that we will get one level deeper into the architecture, right? But am I clear on so far? So whenever you're working with Kubernetes, this is basically your workflow. And one more thing, okay, the most important thing which I want you guys to understand whenever you're working with Kubernetes is, okay, pet versus cat. Okay, let us assume that you have a pet your home, okay, something is not good with that pet. So the health of pet is not doing good. Okay. So what will be your mental situation? You will also be worried, right? Now you have a huge cattle farm. Okay. So in that there are a lot of what do you call cows or animals, whatever it is. It can be even birds. In that, for out of 1,000 birds or 1,000 animals, one animal is not feeling good. What will be your mental situation? Still you will be worried, right? అప్పుడు మీరు అలా వరి అవుతే మీరు పక్షిరాజని అయిపోతారు, మనిషి ఎవరు, right? Okay. For the people who have not understood what's robo, I am not sure I'll, right? There Akshay Kumar will be worried about all the birds on this planet. So we don't have that such great human beings, right? Okay. The whole point is pet versus cattle. There will be a difference, right? Yeah. So let us assume if you have a farm and in that farm one cattle has died. Okay. So what will you do? You'll bring one more. You will not be emotionally attached to it. But when the same thing happens to some your pet, then yes. Now let me try to relate why I am trying to tell this story. Okay. In our companies, what we do is we'll have servers. We'll remember servers by their IP addresses. We'll touch them. We'll feel them. Right. ఈ సర్వర్కి ఏమన్నా అవుతే మనకి పని ఆగిపోద్ది. Okay. So our major intention is to get that stuff repaired or get it back working. Cattle means throw it away, bring the new one. Yes. In Kubernetes, we work with Kubernetes as if they are cattle, not pets. Okay. In the Docker Swarm also same story. They are not working, they are not working. Okay. Throw them away, ensure that you have all the data and bring a new stuff up and running. Okay. It is not like, okay, I'll be getting into that, I'll be fixing issue. No, bring a new one. Okay. I want to change something in Docker, build a new image, new container. New container means new pod to the Kubernetes, not fixing the older ones. No, that is a traditional way of basically doing it. And whenever you are working with Kubernetes or any cluster technology for that matter, okay, not only Kubernetes, even Docker Swarm, same story, right? So we will not treat of our work as pets. They are actually cattle. If some container is crashing, okay, if it is crashing continuously, then that is a problem that needs to be addressed. But if it is crashing once in 6 months, I'll not be worried. I'll ensure that next time when it crashes, I have the other alternative. I have a high availability of that so that this crash will not impact my application. Am I clear on this? So whenever you're working on this, we work with on a large scale, and fixing individual container issues is not that simple unless it is a functional issue, right? There will be some issues like, okay, on that server, the hard disk is running less in space. Remove that from that list. Okay. Kubernetes knows how to manage the stuff with other nodes, right? So yesterday itself, I think in Docker Swarm also, when we killed the container, what was happening? It was bringing one more. It was not trying to repair the older one. Okay. So this technologies work in that cattle fashion, not in a pet fashion. Okay. Still we will have that admin mindset kada, man admin kada, man roju poddun legitte enti that server is not working, go and fix it. Yes. Here also you'll fix it, but you will not fix by basically getting into the older content. You will get into the older stuff to understand the problem, and you will ensure that that problem will not be occurring in the next set of containers that are going to be created. Am I clear on that? So that is exactly what is basically present over here. Let me go to the last. Okay, pets are given the name. Okay, I am quite sure that you might remember the servers which you use in your office by IP addresses, by names and all of that stuff. In Kubernetes, I'll not give it. Let it whatever name with it. For me, whether it is working or not, that is important. So if you go through this whole stuff, you will understand what is the mindset. Okay, so am I clear on this? So our servers are no longer these cute animals, right? Our Kubernetes work will be like you have a huge dairy farm, అంటే చంద్రబాబు నాయుడు గారికి హెరిటేజ్ పాల ఫామ్ ఉన్నట్టు మీకు కూడా పెద్ద పాల ఫామ్ ఉంది. ఇప్పుడు అందులో ఒక ఆవు చచ్చిపోతే చంద్రబాబు నాయుడు మానసిక స్థితి ఏమన్నా మారుతుందా? ఏం మారుతుంది? right? The same thing. You also believe in that fashion, right? Am I clear on this? Yeah. So this is a basic mindset to get the things working down in the stuff. So for the people who didn't understood it, our Chandrababu Naidu has a heritage farm, right? And which is a very huge dairy products. So if one of the animal dies there, will it impact Chandrababu Naidu's mindset? No. So you also behave like him. That's what I'm trying to tell. Right. So if one server goes, if one pod gets killed out of 100, so if there is no alternative, yeah, we should be worried. So you have said that run this, scale this to 100 containers, and one container has crashed. Why are you worried? You have 99 more. Yeah, and Kubernetes will automatically bring one more, obviously, right? So just like what we have said yesterday, we have put the containers number to 3. We have gone and stopped one container. Then what was happening? One more was launched. Same thing Kubernetes will do anyway, right? So think of this and just go through this image. It will try to tell you the whole story. Okay. So whenever you are working with Kubernetes or Docker Swarm or any cloud-based technology, even in cloud, right? There is no need for you to fix servers. Bring one more. Bring one more. Right. So that's the whole mindset. Okay. This pet mindset is basically for the people who work in data centers. Right. In your offices, you will have servers. Right. That server might be procured. Your company might have paid a lot of amount for that and all that stuff. But here we are not doing that, right? So we work in altogether a different fashion. Clear on that? Yes. Okay. So I'll just give a link to this image. Clear? Okay. So today only 3 takeaways, right? Kubernetes we are using, okay, because it has come from a proven platform. It has come from a proven platform. The second thing is Kubernetes high level architecture is much like Docker Swarm. Much like Docker Swarm. But to speak with Kubernetes masters, we have 2 ways. One is you have a command line way, which is called as kubectl, and then we have a API based. Okay, and we always speak with masters, and masters will get the work done on. So till this point, there is literally no difference between Docker Swarm and Docker Kubernetes, right? So fine. And in Kubernetes or in Docker, what we treat is we treat our infrastructure, whatever we are going to create, as cattle, not as pets. Clear on that? Yes? Okay, good. So fine. This was the first view. Now what we'll do is we'll take this first view and then slowly we'll add these components. So are you seeing these components? Okay. Today I've not spoken about the 4 components of the Kubernetes master and the 3 components of your node. Okay, right. So we'll be getting into all of this. Okay, right. Now just I will try to speak about cloud or Kubernetes as a service. So right now to make Kubernetes work, what do you need? You need servers. Okay, so this master is one Linux server or whatever server it is. Right. So this node is also one server. So yesterday for creating Docker Swarm, we have taken 3 servers. One was manager, 2 were node. Yeah, workers. So here also, if you want the same story, you will be taking one as a master, the other 2 as nodes. So if you are installing Kubernetes in your office, you have to basically create masters. You have to ensure that masters are replicated somehow, so that if one master goes down, you will ensure that the other master is available. You have to do all that settings. But if you go to the cloud, what happens is cloud will give you master straight away. In cloud, if you go to Amazon EKS, Elastic Kubernetes Service, and then you say that I want to get a new Elastic Kubernetes service, then basically what you get is you get these master servers. Okay, and then what you are supposed to create is nodes. What you are supposed to create is nodes. So for giving that master servers, they will have hourly charges. So for per hour, I'll charge you this much. And the best part of that is, if you go to the cloud, you need not set up replications between them. Okay. If any of the server goes down, bringing up is cloud's responsibility, not ours. Right. But if you set it up in your office, if that goes down, and if you have only one server, you should be worried about, because your whole cluster will be down. Okay. So when you go to Kubernetes as a service, what is that we get? We get masters already given to us by the cloud provider. You go to the Azure Kubernetes service, same thing happens. You go to the EKS, same thing happens. You go to the GKS, same thing happens. Okay. So in all the Kubernetes as a service, what is that we get readily available? Masters are available. Then you need to configure that masters, add nodes, and ensure that your Kubernetes works. Am I clear on that? But we'll be discussing that on a deeper note. But I just wanted to give a high level overview. So what are the topics that will be on the cloud or which will be given as a service? Masters. Okay, you will not have a login access into masters. You need not worry about them because someone else is managing it. Okay, you will be given a kubectl access and an API access, and for you nothing changes. You work with kubectl, you work with this, and this master will be able to speak with the nodes whatever you create on that cloud. Yeah. So in the case of AWS, each node will be a EC2 machine which you will create. In the case of Azure, each node will be a virtual machine which you are going to create in Azure. Okay. In the case of GKS, the story is same. You go to any cloud, the story is same. Am I clear on that? Yes. So when we go to Kubernetes as a service, what is that we get? We get there is no need for you to worry about master. The only thing which you need to worry about is nodes. That's it. Okay. And now volumes. Your volumes can be on the cloud. You will get all of that stuff. Right. So clear on this? So what is EKS now? In EKS, Amazon has given a service where they will manage masters for us in Amazon cloud. But rest of it is same Kubernetes. Okay, nothing changes. Rest of it is same Kubernetes. If you want to speak with Kubernetes, you have to go with either kubectl or API. If you go to the Azure cloud, story is same, right? So Azure will manage the master servers for you, and it will ensure that you can speak with kubectl with that. Okay, it will give you all the benefits of taking backup server being. If your masters are going down, you need not be worried because that is cloud providers headache. Clear on this? Right. Okay. Fine. So right. No voice, baboy. No voice అంటే సచ్చేపోతాను ఇప్పుడు. When you will tell a project for DevOps who have completed, oh, only one task, you have to complete 4 tasks. It's not that simple, sir. Life is not that simple. Okay. Finish the Terraform task. Finish 4 tools tasks. Okay. You have done 1. Good. You have 3 more. Okay. Right. If you have finished the 3, and I think I have given all the tasks at the end of every course. For Ansible, I have given it. For Jenkins, I have given it. Right. So show me 4 tasks, then we'll worry about it. Okay. Right. Right. ELB like AWS, I'm not discussing about that. Are you going to teach rest of Docker file concepts on Docker Compose? No way. I'm not going to speak about Docker Compose. Okay. Docker Compose is a useless topic. Okay. The reason is it works only on developer's laptop. If I'm a developer, I'll be worried on Docker Compose because I have to set it up locally. Okay. Not really for production grade. Docker Compose is never used in production, so I'm not interested. Right. Okay. But if you still want it, okay, if the time permits, I can tell how to write that YAML file. Okay. Right. Okay. What is Borg? Okay. Borg is a product that is designed by Google to make your Google search work. Okay. It is a private product which is not exposed to the outside world. So Google's in-house product, right? But the only thing which we know about Borg is the name. We will not know about the architecture of it because it is an in-house product. Okay. Yeah. Okay. Leader, manager, control, everything is same. Yes. Yeah. For now, you can think all of that as same. Okay. How many containers can we accommodate in a pod? How many uh, basically Docker containers can I have in one machine? Same story. Same story with respect to the stuff. But did I define what is pod? No, right? Why are you worried, man? Okay, that is my problem, right? Yeah. So, and there was one question about Docker file. And if you have, I think in yesterday's class or day before yesterday's class, I have said that saying that Docker files, rest of the concepts will be covered over the weekend because there is some other data which I need to speak to. Okay, right. Yeah. Okay. నాకు ఆ స్వేచ్ఛ లేదండి, మీకున్న స్వేచ్ఛ. What is pod? What is its purpose? Stay tuned for tomorrow's class. Right? What is production environment in Kubernetes? In company JD, they mentioned 2 years experience in production environment in Kubernetes. Yeah, that's fine. But today itself we have started Kubernetes, right? Yeah. Let us wait. Okay. We have come too far into Docker. Yes. On the day from which we started Docker, the same thing will happen in Kubernetes also. Okay. Just have trust on me. I'll answer all of your questions. Some of the times me answering the questions might have very bad impact on you. Those are the cases where I'll not answer the questions, right? Okay. Please provide alternative solutions for videos who are Mac. I see you always have that challenge, right? So out of 300 people, there will be one Mac user. Okay. So, and for me, it takes a decent amount of effort. Okay. So that's the whole point why I'm not doing it for Mac. Yeah. Is Docker completed? Sir, please listen to all the classes of mine. Okay. So I'm quite sure that you have not attended couple of days classes, right? So in one class I have said that we still have Docker topics to be discussed, and that will be covered over the weekend. Yeah, please. Okay, I'll not skip topics, sir. This is for sure. If there are certain topics to skip, we will stretch our weekends, but no topic skipping, right? Now we will do servers or in cloud Azure. We will do on our own servers and then we'll go to the cloud, because we have to know pain points, right? Yeah. So, right. Yes. When it comes to reality, okay, will we work on Kubernetes rather than Docker? Okay. Kubernetes reality will not exist if you don't have Docker. So if you don't have Docker image, there is no Kubernetes that is going to happen. So all of that which we have said is also reality. And once you finish that reality, you will be coming into Kubernetes reality. Because without running Docker or without having Docker images, you can't run Kubernetes, right? Yeah. And to build the Docker images to basically do all of that, we need to have. And there are some companies who don't use Kubernetes and they use only Docker containers. Yeah. We never know, right? That is your company's architecture, right? Is the same raft algorithm used over here? Yes. Okay. You said you will be giving. I'll do that, sir. Okay. 1-to-1 expected Saturday. Okay. How to make a good at AML? What do you got? So you want to become good at all of that. Start working on it. So I wanted to become good at gym. I've never been to gym till date. Right? Will it help? No. Okay. Right. ఇప్పుడు మాక్సిమం గా అప్పుడు నాకు జనాలు చెప్పే సలహా ఏంటంటే క్రమశిక్షణ ఒకటి పెట్టుకో జీవితంలో. హ్యావ్ ఎ డిసిప్లిన్ ఇన్ యువర్ లైఫ్ ఇఫ్ యూ వాంట్ టు బి ఫిట్. దట్స్ ద ఫీడ్బ్యాక్ విచ్ ఐ గాట్. సో ఐ విల్ ఆల్సో గివ్ యూ ద సిమిలర్ ఫీడ్బ్యాక్. యా. Yeah, man, I have lot of expectations and unfortunately that is true. Okay. But remember one thing, I can just guide you. I'll not be able to do your stuff. Yeah. So, right. Any Docker use cases to practice? Not right now. Not right now. Okay. I'll give when the time comes. Right. Saturday, Sunday schedule, please. Okay. I work, even I am working, sir. Right. Okay. Okay. Right, man. Okay. Fine then. So, this is what we have agreed to. Saturday, 7 to 10 a.m. Kubernetes. K8s is Kubernetes. If you count the characters between K and S, there will be 8 characters. There was some lazy person who has came up with this notation, which is working very well for me. Right? I don't want to type all of that Kubernetes. Kubernetes rase badlu K8s and asta. If you count number of letters between K and S in Kubernetes, it is exactly 8 characters. That's where whenever you see K8s, it is Kubernetes. Right? And then 6 to 9 p.m. we'll be speaking about foundations, and in this foundation class we'll be speaking 1.5 hour of networking and 1.5 hour of the storage aspects of it, right? Okay. And let me see if I can do something over there. If I can, whatever content which I have to deliver, if I can give it earlier to you, so that we will be able to work on the practical things rather than listening to the topics. That's the whole idea. But let me see. I don't want to promise anything over here, but let me see what I can do. Right? Okay. Fine. And on Sunday, 7 to 10 a.m. we have Kubernetes. Right? So this is our weekend schedule. Clear on this? Right? Okay. So fine. I have to give you YAML, right? Okay. So today I'll do one thing. If I can make a YAML content available, fine. Otherwise, from Quality Thought, you will get a mail where the YAML tutorial is available, right? You just go through that. Okay. So by evening, you will get that, right? By evening, just have a look at, by 7 or 8 o'clock, have a look at the Direct DevOps blog. Okay. So if you are, so I'm not sure the best way. I'm still. So if I was you, okay, whenever any updates happen, are you seeing this follow link? If you give your email address over here, whenever something changes in this, you will get an email. That is much most easier way to follow, right? So adi pedda kharchuto kuda koodukona pani kaadu. Just put your email address and click on the follow button. Then basically, whenever a new content comes into this, you will get an alert. It's like యూట్యూబ్ సింబల్ లో గంట సింబల్ కొడతాం కదా, దగ్గర ఆ గంట లాగే పని చేస్తుంది. యా, బట్ దేర్ యూ విల్ హియర్ యూ విల్ గెట్ అన్ ఈమెయిల్. యా, ఓకే. ఓకే దెన్. యా, ఫైన్. Can we have an Active Directory foundation? Yeah, yes, sir. Sir, the point is we have too many gaps and have to discuss too many topics. So Active Directory foundation classes will be happening somewhere closer to our Active Directory need in Azure. So right now, for whatever we are going to discuss, I am not seeing Active Directories quite recently. It might take some more time. So at least nothing less than at least 1 month it will take for me to go there. Okay, right. Fine then. So I'll stop it over here, and then we'll continue with this discussion over in the next class. Right? Okay. Thanks.